Okay, let's look into question number 26. A company is developing a new application that needs to process transactions in real time. The company wants to ensure that all transactions are processed in order and that no transaction is lost. Which of this is correct strategy for leveraging OCI queue in this scenario? Okay, let's look into the options. Use a single queue to process all transactions. A single queue ensures messages order and simplify tracking to prevent loss. So option A looking a good answer, let's keep it. Moving on to option number B. Use a priority queue to prioritize request. OCI queue does not support native priority based message handling. So option B and it's not a good answer. Moving on to option number C. Use a separate queue for each application instance. Using separate queues for instance dispute message ordering and complicates coordinated process. So option C again a wrong choice. Moving on to option number D. Use a separate queue for each type of transactions. Splitting queues for type risk out of orders processing across types. So option D it's not a correct choice. So option A will be the correct one. Okay, let's look into question number 27. You are developing a real-time monitoring application for a fleet of vehicles which will be deployed in Oracle Cloud Infrastructure. You need to choose between using OCI Queue or OCI streaming to handle the real-time data feeds from the vehicles. Based on the scenario described, which of this most appropriate choice for handling real-time data feeds? Okay, let's look into the options. Option E, OCI queue because it's provide at least one message delivery which is critical for real-time monitoring applications. OCI queue is better suited for distinct tasks, not continuous telemetry streams. So option A is not a good answer. Moving on to option number B, OCI streaming because it offers exactly one message delivery which is necessary for real-time applications. OCI streaming offers at least one delivery by default, exact one requires additional configurations. So option B again a wrong choice. Moving on to option number C, OCI Queue because it is optimized for low latency messaging and ideal for real-time applications. While low latency is useful, OCI Queue isn't built for high throughput real-time data feeds. So option C again a wrong choice. Moving on to option number D, OCI streaming because it is designed for high volume continuous ingestion and processing of data, making it the best choice for fleet of vehicles. OCI streaming is built for high throughput continuous data injection, making it ideal for vehicle telemetries. So option D will be the correct one. Okay, let's look into question number 28. Which of these is a valid use case for OCI queue? Okay, let's look into the options. Build decoupled and scalable system. OCI queue enable synchronous messages to decouple components and scalable independently. So option A looking a good answer. Moving on to option number B, sending real-time streaming data. OCI streaming is designed for continuous high throughput data feeds, not OCI queue. So option B it's not a good answer. Moving on to option number C, storing and retrieving large files. So OCI queue is not storage services. Use OCI object storage for large files. So option C is not a good choice. Moving on to option number D, managing network traffic between OCI services. OCI queue handles message delivery, not network traffic routing or load balancing. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 29. When developing microservices, each one of the one be developed in the language of your choice. Which term describes this type of development? Okay, let's look into the options. Option A, distributed. Distributed refers to a system architecture across multiple nodes, not language diversity in microservices. So option A not a good choice. Moving on to option number B, polyglot. Polyglot developed services allow services in built using different programming languages best suited for each services. So option B looking a good answer. Moving on to option number C, DevOps. DevOps focuses on automation and collaboration between development and operations, not language diversity in microservices. So option C not a good choice. Moving on to option number D, Agile. Agile refers to iterative development practice, not language diversity in microservices. So option D again a wrong choice. So option B will be the correct one. Okay, let's look in question number 30. Which statement about microservices is false? Okay, let's look into the options. They are typically designed around business capabilities. Microservices are modeled on distinct business functions to promote modularity. So option A not a good choice. Moving on to option number B, multiple microservices can run in one process. Microservices are meant to run separate processes to ensure isolation and independently scalability, not in one process. So option B looking a good answer. Moving on to option number C, they are independently developable. Each microservices are developed and updated and scaled without affecting others. So option C is not a good answer. Moving on to option number D, it is fairly common for them to communicate with HTTPs. HTTP/REST is a common protocol for inter-services communication in microservices. So option D is not a good choice. So option B will be the correct one. Okay, let's look into question number 31. As a developer, you have been asked to develop an e-commerce website for your organization. Your website must support different clients including desktop browsers, mobile browsers, and native mobile applications. Which two approach would you use to build an application that is resilient to architectural changes, has development independency, and allow easier technology upgrades? Okay, let's look into the options. Use a monolithic approach because it makes it easier to incrementally adapt to new technology. Monoliths are tightly cooped, make technology upgrade harder across the task. So option A not a good answer. Moving on to option number B. Use a monolithic approach to perform frequent updates because it allows you to easily redeploy your applications. Redeploying a monolith requires updating the entire application, reducing flexibility. So option B again not a good choice. Moving on to option number C. Use a microservice architecture because it eliminates any long-term commitments to a technology stack. Microservice allows each service to use and evolve its own tech stacks. So option C looking a good answer. Let's keep it. Moving on to option number D. Implement each module as an independent service/process which can be replaced, updated, or deleted without disrupting the rest of the applications. Modular service enable isolate updates and replacements without system disruptions. So option C and D will be the correct choice. Which is a valid Okay, let's look into question number 32. Which is a valid reason for choosing to implement a serverless architectures? Okay, let's look into the options. Option A, improve in function state management. Serverless functions are stateless by design, making state management more complex. So option A not a good choice. Moving on to option number B, easier to run long running operations. Serverless are optimized for short term live tasks. Long running operations may hit execution limits. So option B again a wrong choice. Moving on to option number C, no need for integration testing. Integration testing is still essential in serverless application to ensure components integration. So option C again a wrong choice. Moving on to option number D, reduce operational cost. Serverless eliminates servers management and use a pay per use model, lowering infrastructure cost. So option D will be the correct choice. Okay, let's look into question number 33. As a developer using Oracle Cloud Infrastructure API Gateway needs to authenticate the API request to their web applications, the authentication process must be implemented using a custom scheme which accepts string-based parameters from a API caller. Which approach should the developer use in this scenario? Okay, let's look into the options. Option A, create a cross-account function authorizer. Cross-account function authorizer is used for granting access across OCI tenancy, not for custom string-based authentication. Option A, not a good choice. Moving on to option number B, create the authorizer function using request header authorization. Request header authorization allows custom string parameters to be passed and validated by an authorizer functions. So option B looking a good answer. Moving on to option number C, create an authorizer function using token-based authorization. Token-based authorization is typically used for standardized tokens like JWT not for custom string based authentication schemes. So option C again a wrong choice. Moving on to option number D, create a authorizer function using OCI identity and access management based authentications. OCI IAM based authentication is used for identity management, not for implementing custom string based authentication schemes. So option D again a wrong choice. So option B will be the correct one. Okay, let's look into question number 34. You have two microservices A and B running in productions. Service A relies on APIs from service B. You want to test changes to service A without deploying all the dependency, which includes service B. Which approach should you take to test the service A? Okay, let's look into the options. Option A. This is not possible because service B is dependency. Dependency like service B can be simulated using mock, making isolated testing for service as a possible. So option A not a good choice. Moving on to option number B, testing using an API mock of service B. Using an API mock of service B enable isolated testing for service A with control and predictable responses. So option B looking a good answer. Let's keep it. Moving on to option number C, test using the current production version of service B. Testing the current production version of service B risks instability and does not isolate service A from control testing. So option C again a wrong choice. Moving on to option number D, test using a previous test version for service B. A previous test version of service B may be not reflected current behavior, leading to unreliable testing for service A. So option D again a wrong choice. So option B will be the correct one. Okay, let's look into question number 35. Which of these is not a valid authentication method for accessing an OCI API gateway development? Okay, let's look into the options. Option A, HTTP basic. HTTP basic authentication is supported by OCI API gateway for simple credential based access. So option A not a good choice. Moving on to option number B, OAuth. OAuth API gateway supports OAuth 2 authentication through integration and Oracle Identity Cloud Service gateways. So option B again a wrong choice. Moving on to option number C, SAML token. SAML tokens are used for federation identity and not for supported for direct authentication in OCI API gateway. So option C looking a good answer. Moving on to option number D, API key. API key authentication is supported by OCI API gateway through headers based validation. So option D again a wrong choice. So option C will be the correct one. Okay, let's look into question number 36. Which term describes a group formed by a master machine and a worker machine in a Kubernetes architecture? Okay, let's look into the options. Option A, pod. A pod is the smallest deployment unit in Kubernetes, not a group of machines. So option A not a good answer. Moving on to option number B, development. Development manages more pod replicas, not our infrastructure grouping. So option B again a wrong choice. Moving on to option number C, containers. Containers runs inside pods and are not a part of node level architectures. So option C is not a good choice. Moving on to option number D, cluster. Kubernetes cluster includes both master and workers nodes working together to manage and run containerized applications. So option D will be the correct choice. Okay, let's look into question number 37. Kubernetes includes various elements such as compute, network, and storage. Compute is essential for GPU, CPU, and memories within an OCI cluster. What is considered to be the smallest unit to development with respect to compute? Okay, let's look into the options. Option A, containers. Containers run inside pod cannot be deployed independently in Kubernetes. So option A not a good choice. Moving on to option number B, namespace. Namespace is a logical grouping, not a deployable compute unit. So option B again a wrong choice. Moving on to option number C, pod. A pod is the smallest deployment units in Kubernetes. Hence capability one or more containers. So option C looking a good answer. Let's keep it. Moving on to option number D, service. A service exposes pods, but it's not compute unit itself. So option D again a wrong choice. So option C will be the correct one. Okay, let's look into question number 38. Which service can act as destination for OCI events actions? Okay, let's look into the options. Autoscaling. Autoscaling reacts to metrics but not in direct destination for OCI event actions. So option A definitely not a correct choice. Moving on to option number B, virtual cloud network. VCN is a network construct, not a service that receives events payloads. So option B again a wrong choice. Moving on to option number C, notifications. OCI notification service is designed to receive and distribute message triggered by events. So option C looking a good answer. Let's keep it. Moving on to option number D, compute. Compute instance can generate events but are not typically designed decide destination for event actions. So option D again a wrong choice. So option C will be the correct one. Okay, let's look into question number 39. Which action type option is not available in Oracle Cloud Infrastructure Events Rule definitions? Okay, let's look into the options. Option A, streaming. OCI events can trigger streaming services to handle event data simultaneously. So option A not a good choice. Moving on to option number B, functions. OCI functions can be invoked directly by events rule for custom logic executions. So option B again a wrong choice. Moving on to option number C, email. Email is not a direct action type in OCI events. It must be triggered through the notification services. So option C looking a good answer. Let's keep it. Moving on to option number D, notification. Notification is supported action type of distributing event messages. So option D again a wrong choice. So option C will be the correct one. Okay, let's look into question number 40. Your development team decided to create and deploy some business logic for serverless Oracle functions. You are asked to help facilitate the monitoring, logging, and tracing of the services, which is not valid for troubleshooting Oracle functions. Okay, let's look into the options. Option A, Oracle function metrics are available only at the application level. Oracle function metrics are available at both application and function levels, not just in application level. So option A looking a good choice. Moving on to option number B. Oracle function tracing can be configured at the function level. Tracing is an Oracle function can be configured at the individual function level for detailed performing insights. So option B again a wrong choice. Moving on to option number C. Oracle function invocation logging must be explicitly enabled by the user. Invocation logging in Oracle function must be explicitly enabled by the users to capture execution details. So option C again a wrong choice. Moving on to option number D. Oracle function invocation logs require enabling at the application level. Invocation logging for Oracle function must be enabled at the application level before function levels logs are available. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 41. You encounter an unexpected error when invoking Oracle functions from your Cloud Shell session. Name my function in the my app applications. Which option will get your more information on the error? Okay, let's look into the options. Option A. The debug flag provides detailed diagnosed output when invoking Oracle function using the FNCL CLI. So option A looking a good answer. Moving on to option number B. B. Verbose increase output details but does not provide full debug level diagnosed. So option B not a good choice. Moving on to option number C. C. Debug 1 is not a valid FNCLI flag and will result in syntax error. So option C again a wrong choice. So option A will be the correct one. Okay, let's look into question number 42. Which statement regarding virtual nodes is true? Okay, let's look into the options. Option A. Virtual node supports only VCN native pod networking and the Flannel CNI plugin is not supported. Virtual nodes in OCI supports only VCN native pod networking. Flannel CNI is not compatible. So option A looking a good answer. Let's keep it. Moving on to option number B. Virtual nodes are managed by users and require manual upgrades. Virtual nodes are fully managed by OCI and do not require manual upgrades. So option B not a good choice. Moving on to option number C. Load balancing in virtual nodes is between workers nodes. Virtual nodes abstract away from worker nodes. Load balancing occurs in pod levels. So option C again a wrong choice. Moving on to option number D. Resource allocation in virtual nodes is at worker node level. Virtual node eliminates direct work node management. Resources are allocated per pods. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 43. As a DevOps engineer working on managing clusters on the OCI platform for your organization, which statement is false by managing clusters add-on in OCI OKey clusters? Okay, let's look into the options. Option A, you can opt in to and out of automatic updates by the oracles. OCI allows users to enable or disable automatic updates for cluster add-ons. So option is not a good choice. Moving on to option number B. When enabling a cluster add-on, you can configure the add-ons by specify one or more key/values pairs to pass an argument to the cluster's add-on. Add-ons can be customized using key/value arguments during enablement. So option B again a wrong choice. Moving on to option number C. When you disable a cluster add-on using the console, the add-ons is removed from the cluster. Disabling a add-on does not remove it. Components may remain in the cluster. So option C looking a good answer. Moving on to option number D. When creating a new cluster, essential cluster add-on cannot be disabled. Core add-ons are mandatory and cannot be disabled during cluster creations. So option D again a wrong choice. So option C will be the correct one. Okay, let's look into question number 44. Which of the following step is not required for setting up the container engine for Kubernetes OCI clusters access using the local installation for Kubex? Okay, let's look into the options. Option E, generate an API signing key pair and upload the public key for the API signing key pair. Generating and uploading an API key signing key pair is required for authentication OCI CLI operation for access and OCI clusters. So option A not a good answer. Moving on to option number B. Install and configure the Oracle Cloud Infrastructure CLI. OCI CLI is used for generating the queue configuration file for Kubex access. So option B again a wrong choice. Moving on to option number C. Generate auth token from the OCI console to access the OCI cluster using Kubex. Auth tokens are not manually generated from the console. They enabled via OCI CLI during configuration kube configuration setup. So option C looking a good answer. Moving on to option number D, set up the kube configuration file. The kube configuration file is essential for Kubex to connect in the OCI cluster. So option D again a wrong choice. So option C will be the correct one. Okay, let's look into question number 45. A service you are developing to Oracle Cloud Infrastructure Container Engine for Kubernetes used a Docker image from a private repository in OCI registry. Which configuration is necessary to provide access to the repository from OCI? Okay, let's look into the options. Option A, create a Docker registry secret from OCIR with identity or token to the cluster and specify the image pull secret property in the application development manifest. Access private OCIR images from OCI cluster requires a Docker registry secret using an auth token and referring the via image pull secrets. So option A looking a good answer. Moving on to option number B, create a Docker registry secret for OCIR with API key credential on the cluster and specify the image pull secret property in the application's development manifest. OCI registry does not support API keys for Docker's logins or image pulls. So option B it's not a good answer. Moving on to option number C, add a generic secret on the cluster containing your identity credentials. They specify a registry credential property in the development manifest. Registry credential is not a valid Kubernetes manifest property. So option C again a wrong choice. Moving on to option number D, create a dynamic group for nodes in the cluster and a policy that allows the dynamic group to read repositories in the same compartment. Dynamic groups and policies are used for IAM access control, not for enabling image pull from OCIR using image pull secrets. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 46. Which of the following statement is true about deleting the Kubernetes clusters? Okay, let's look into the options. Option A. If you change the auto-generated name of a worker node and then delete the cluster, the renamed worker node is not deleted. Remaining does not prevent deletion. Worker nodes is removed with the clusters. So option A not a good choice. Moving on to option number B. Changing the auto-generated name of the worker node does not affect the deletion of the worker nodes when the cluster is in which it is created is deleted. Worker nodes are deleted regardless of name changes when the cluster is deleted. So option B is looking a good answer. Moving on to option number C. You cannot change the auto-generated name of the worker nodes in the format of this. Auto-generated names can be changed, though it's not recommended. So option C again a wrong choice. Moving on to option number D. Upon deleting a cluster, other resources creating during the cluster creation process are associated with the clusters. NAT gateway, tables, security lists, load balancer, and block volumes are deleted automatically. Resources like VCNs and gateway must be manually deleted after cluster removal. So option D again a wrong choice. So option B will be the correct one. Okay, let's look into question number 47. Your organization has deployed their e-commerce application in Oracle Cloud Container Engine for Kubernetes, and they are using the Oracle Cloud Infrastructure Registry service as their Docker image repository. They have deployed the OCI cluster using the custom create option, and their virtual cloud network has 3 public subnets with associated route tables, security list, and internet gateway. However, their application containers are failing to deploy. On investigation, they discover that the images are not being pulled from the destination designated OCIR repositories, even though the YAML configuration has the correct path to the images. What is a valid concern here that needs to be further investigated? Okay, let's look into the options. Option A, key cluster need to have a secret with the credential of their OCI repositories and use that secret in Kubernetes development manifest. Private OCI requires a Docker registry secret and image pull secret refers in the manifest. So option A looking a good answer, let's keep it. Moving on to option number B, security list rules for TCP port 22 needs to be added to connect to the OCIR services. Port 22 is used for SSH, not for accessing OCIR, irrelevant for image pull issues. So option B again a wrong choice. Moving on to option number C, identity and access management credentials need to be added for each other users that deploy application to the OCI clusters. IAM credentials are not required per users for deploying applications. Access to OCIR is managed through Kubernetes secrets. So option C again a wrong choice. Moving on to option number D, VCN hosting the OCI cluster worker nodes needs to have a NAT gateway to access OCI repositories. Public subnets already have internet access via internet gateway. NAT is needed only for private subnets. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 48. As a DevOps engineer tasked with setting up a new OCI cluster for your organization Kubernetes applications, which statement is false regardless the preparation process? Okay, let's look into the options. Option A, you must have access to an Oracle Cloud Infrastructure tenancy. Access to an OCI tenancy is mandatory to create and manage OCI clusters. So option A not a good choice. Moving on to option number B, container engine for Kubernetes automatically create and configure new network resources for the new clusters. The quick create workflow automatically provisions required network resources. So option B again a wrong choice. Moving on to option number C, container engine for Kubernetes cannot use existing network resources for the creation of a new cluster. The custom create workflows allow using Pre-configuration network user flows. So option C looking a good answer. Let's keep it. Moving on to option number D. Your tenancy must have sufficient quota on different types of resources. Sufficient quota for compute, networking, and service limited is essential. So option D again a wrong choice. So option C will be the correct one. Okay, let's look into question number 49. As a Kubernetes administrator, you are tasked with setting up local access to a Kubernetes cluster with a private API endpoint. Which step is involved in the setup process? Okay, let's look into the options. Option A, setting up a bastion using the Oracle Cloud Infrastructure Bastion service. Bastion services require access to the cluster with private API endpoint by tunneling traffic through a control entry point. So option A looking a good answer. Let's keep it. Moving on to option number B, using a Cloud Shell to directly connect to the Kubernetes cluster private API endpoint. Cloud Shell cannot be connect to API endpoints. It requires public access to a Bastion tunnel. So option B not a good choice. Moving on to option number C, installing and configuring Helm CLI. Helm is used for packaging management in Kubernetes, not essential for establishing cluster access. So option C again a wrong choice. Moving on to option number D, generating an auth token. Auth token is not part of queue configuration setup, but do not enable access to a private endpoint. So option D it's not a good choice. So option A will be the correct one.